Hello everyone, in this video we are going to do some problems on the gas laws and the combined gas law. So let's quickly take a look on all the 4 laws and review them, right? Remember I told you that you have to memorize all of these laws, right? So always remember only Boyle's law is the inverse relationship. Rest other three, the 3, Avogadro, Charles, Gay-Lussac, they are all direct relationship, meaning if you increase one thing the other increases too, right? So Boyle's law is P1 V1 equals P2 V2, meaning PV is always constant. Charles' law is V1 over T1 equals V2 over T2, right? Because V over T is constant, keeping the pressure and number of moles constant. And Gay-Lussac's law is P over T is constant, meaning P1 over T1 is equal to P2 over T2 when the volume and number of moles of the gas are held constant. And Avogadro's number is when pressure and temperature are held constant, the volume of a gas is directly proportional to the number of moles, meaning V over N is constant, which means V1 over N1 is equal to V2 over N2, right? So if we combine Boyle's, Charles and Gay-Lussac's law 1, 2 and 3, when you keep the number of moles of the gas constant, you can get a combined gas law equation, which is PV over T is always a constant, right? And we can write P1 V1 over T1. If you vary the pressure, volume and temperature conditions for a gas when you have the same number of moles and you have a new pressure, volume and temperature conditions, that number is always equal to this, right? So this is what we call combined gas law. Okay, so now let's work on some of the problems on worksheet number 2. So this is our worksheet 2. So I'm going to start with problem number 13. So you have to fill in all the information. So let's do worksheet number 2. I'm going to do problem number 13. So let's first read the problem. 1 liter of a gas at standard temperature and pressure is compressed to 273 ml. Now if you are not sure what is given to you, you can always look at the units of the given quantity. ml is a unit of volume, right? So this means volume is given to you, right? So we start with 1 liter of a gas. You start with 1 liter of the gas, so V1 is 1 liter and the gas was compressed, right? Meaning you increase the pressure to 473 ml. The new volume is 473 ml, meaning the volume decreased, right? Since Boyle's law states that pressure is inversely proportional to its volume. If you increase the volume, pressure will go down. If you increase the pressure, volume will go down, right? So this is what exactly happened in this problem. So as you increase the pressure, the volume will go down, right? So this equation is Boyle's law. And the formula for Boyle's law is P1 V1 equals P2 V2. So you have to write down all the variables and write what you need to solve for, right? So I am going to rearrange this equation to solve for P2 because this is what we are solving for. Right? So since we are solving for P2, if you divide both sides by P2, you are going to get P1 V1 over V2. Right? So now let's plug in all the numbers. So pressure P1 is 1 atm, so 1 atm. Then we have V1 is 1 liter, 1.0 liters. Now since volume should have the same units, all the units should be same, right? So since V1 is in liters, you have to convert the milliliters to liters first, right? So convert 473 milliliters to liters, so that becomes 0.473 liters, right? Now you can see liters and liters cancel out, and you will get your answer in atms, which is the unit of pressure. Okay? So now if you solve, you get P2 is equal to 2.11 atm. So this is your answer. Right? Now let's do another one. So I am going to do question number 2. Sorry, question number 14. So 14 is a sample of a gas at 3 mmHg. So if you review your notes, you will see mmHg is another type of unit of pressure. So you are given the pressure value here. So let's write it in the variables. P1 is given, which is equal to 3 times 10 to the power 3 mmHg, right? And then inside a steel tank is cooled from this temperature to this temperature. See, the temperature is decreasing, right? So the initial temperature of the tank was 500, so this is your T1, and it was cooled and its temperature dropped to 0 degrees Celsius, so this value is T2, right? So let's write T1, which is 500 degrees Celsius. Right? Now we do not need the temperature in Celsius. Remember, I told you for all the gas law problems you have to use the Kelvin scale. So change the Celsius to Kelvins. So you add 273 Kelvin, right? So this comes out to be 773 kelvins, right? And then T2 is given, so T2 is 0 degrees Celsius, right, plus 273, and you get 273 kelvins. So we have T1, we have T2, we have P1, and now we need to solve for P2. Since we are keeping the volume and number of moles constant, they are not changing, we are only dealing with these two. So pressure and temperature are directly related to each other, right? So this is Gay-Lussac's law, right? And the formula is P1 over T1 is equal to P2 over T2, right? Since we are solving for P2, right? So rearrange this equation to solve for P2. So P2 is equal to P1 times T2 over T1, right? And then plug in the numbers. P1 is 3.00 times 10 to the power 3, that is mmHg. And then temperature 2 is 273 kelvins. This divided by T1, which is 773 kelvins. Now you can cancel out the units. So Kelvin and Kelvin cancel out and you are left with mm of Hg. When you solve, you get pressure 2. The new pressure comes out to be 1059.51 mmHg, right? Now you can convert that into scientific notation, right? So if I want scientific notation in my answer, I can rewrite this as 1.06 times, since I move the decimal to 3 places to the left, so 1, 2 and 3, so 10 to the power 3 mmHg. So this is your answer. Okay. Now let's do another problem. I'm going to do number 16 now. So this question is, let's see what law is this. If a balloon already has 0.05 moles of helium gas in it, so we are given the number of moles of the gas. So this is N1 that is given to you, right? And it has a volume of 500 ml. So this is V1. How many moles of the gas would it be holding if it ends up in this volume? So we are given volume 2, the new volume, and you are asked how many moles will be there if the volume is this, right? So how many moles? You are solving for N2, right? Since we are dealing with volume and number of mole relationship, this is Avogadro's law. You need to memorize all those, right? And the equation is V1 over N1 is equal to V2 over N2, right? Now let's write down all the variables. N1 is given to be 0.05 moles, right? And volume is given to be 500 mLs. We can change that to liters because the final volume is in liters, right? So if you divide that by 1000, right, and you are going to get 0.5 liters, okay? And new volume is 1.2 liters, right? And we can solve for N2, the new number of moles, right? Now since we are solving for N2, you can rearrange this equation to solve for N2. So if you rearrange, you are going to see that N2 is equal to V2 times N1 over V1, right? So just cross multiply and rearrange to solve for N2. You're gonna see that you're gonna get this, right? Now plug in the numbers. N2 is equal to 1.2 liters times 0.05 moles helium and divided by the new volume, sorry, the initial volume, that was 0.5 liters, V1, right? And you can see the liters cancel with liters and you get your answer in moles. So if you solve that, you will get N2 equals 0.12 moles of helium gas, right? Next we are going to do, maybe, let's see, so we can do number 19. So let's do number 19. Calculate the final pressure inside, right? Inside a scuba tank after it cools from, so this is T1, so this is T1, and it cools to this temperature. The temperature drops. See, this is 10 to the power 3 degrees Celsius, and the temperature drops to 25. So this is the new temperature. The initial pressure in the tank is 130 atm. So this is P1. Okay. Now you don't forget that you have to calculate the pressure in psi. Okay. So you need to check the conversion factors that I gave you in your notebook, Gluin. Remember, I gave you the Gluins. It has all the conversion factors. So you need to convert the pressure to psi's. Okay. So let's start. The temperature 1 is given to be 1 times 10 to the power 3. So that means we have 1000, right? So 1000 degrees Celsius plus 273. So that will give you the temperature in Kelvin. So that will be 1273 kelvins. Then we have temperature 2, the final temperature. It is 25 degrees Celsius plus 273. That will be 298 kelvins. Right? Now pressure 1 is given to you. The initial pressure in the tank is 130. Right? So P1 is 130.0 atm, and you are asked to calculate the new pressure. First we will use these expression. So this is a relationship between temperature and pressure. So that is Gay-Lussac's law. And the equation is P1 over T1 is equal to P2 over T2. So now solve for P2. Since we are solving for P2, rearrange this equation to solve for P2. So P2 is equal to P1 times T2 over T1. Right? If you plug in the numbers, you will see you will get pressure 2 equals 30.4 atm. Right? You can plug all the numbers and see pressure 1 is 130 atms and T2 is 298 kelvins, and the temperature 1 is 1273 kelvins. And you can see kelvins and kelvins cancel out and you get your answer in atms, and this is your answer. But since we need the answer in psi, so you have to convert the atm to psi. So when you do the conversion, so you will get 447 psi. Okay. So next I am going to do some problems on the last page of this worksheet, or maybe we'll do one more problem and then I will make another video to solve some of more problems on this worksheet. Okay. So let's do number 21. So I will just show you how to do this. You can plug in the numbers and do it yourself. On hot days, potato chips bags seem to inflate even though they have not been opened. if a 250 ml bag is at a temperature of 19 degrees Celsius and I leave it in my car, which has a temperature of 60 degrees Celsius. So you are given temperature 1 and this is temperature 2, final temperature, right? And you are given the volume of the bag of the potato chips. So this is V1, right? What will be the new volume of the bag? So you are given T1, you are given T2, right? And then you are given V1. So these three things are given to you. You can write down all the values and you are solving for the new volume of the bag of the potato chips, right? Since we are using only two variables, we are seeing how the temperature and volume affect each other. This is a Charles law equation. And Charles law is V1 over T1 equals V2 over T2, right? And you can solve for V2. So rearrange this equation. V2 comes out to be V1 times T2 over T1, right? You can plug in all the numbers and get your answers, okay? So I'll stop this video here, and in the next video we'll do some more problems from the same worksheet.